Hello everyone. So in this lecture, I will discuss two other queries. So I have kept these two queries separately because these queries are far more involved than the ones which we have covered so far. Okay. So here we go. So the first query that we are interested in is we want to find those manufacturers or makers who have at least two different PCs with speeds greater than 2.8, right? So that means this particular manufacturer, he or this particular company should have manufactured at least two different PCs. They could have made three PCs, four PCs, whatever, but the bottom number is 2, right? So just focus on this at least 2. I'll get back to this and tell you that if instead of at least 2, if I had given a query where I would have said that find those manufacturers who have exactly two different PCs, right? So then things have to be done very differently. So this word at least 2 has a very specific way of doing things, right? So let's get into the details here. Okay, so the way we are going to solve this query is first of all, we will take an Cartesian product of PC with PC, right? Because we are interested in two PCs who have speeds greater than 2.8, right? So the query is split into two parts, right? So the first part, in the first part, what we are going to do is that we are going to figure out pairs of PCs whose speeds are greater than 2.8. Let's say that you have 10 PCs in your PC table, and out of that only two PCs have speeds greater than 2.8, right? Lest everything is less than 2.8 gigahertz, right? So now if you want to find pairs of PCs whose speeds are greater than 2.8, then, right, so now how you're going to do? We are going to take a self Cartesian product of PC with PC itself with itself, right? So PC, the first copy has 10 models, let's say, and only two of them have speeds greater than 2.8, right? So if you're going to do a cross product with itself and followed by a selection condition where first this cross product PC1 cross PC2, you'll get 100 pairs, right? And then after I do this selection where PC1 dot model is not equal to PC2 dot model, you might remember this condition from our previous lecture also. Whenever I do this, what I will get, what we are basically doing is that we are basically creating all possible ordered pairs of PC models, right? Where in that pair, the only kind condition is that the model should not be same, right? A model should not be paired with itself, but it can be paired with anybody else, right? So as you might recall that if my PC table has 10 different PCs, each with a unique model number, after doing this operations in R1, I'm going to get 90 pairs, right? Of course, each pair, so these pairs are basically ordered pairs. So if I have a model number 10 and 11, then I'll get two pairs. So one with 10 and 11 and the other one with 11 and 10, right? So you'll get both because we are sort of doing an self join over here. So after we got all possible ordered pairs of PC models where those models are different, we are going to filter out those pairs where the speed of both the PCs is greater than 2.8. Okay, so after we do this, so let's say that we had only two PCs which had a speed greater than 2.8, right? So let's say one model was 100 and the other model was 101, right? So after this first step, we are going to get two pairs. So one having 100 and then 101, and the second pair being 101 and then 100, right? So because we are doing this cross product kind of a thing, so you'll get two pairs, right? Of course, this along with the others, you will get these two, and out. Okay, then after you get those two pairs of PC models. Of course, as I said before, you'll get several other pairs, but yeah, these only the two of them will pass through this selection condition, and then after that, in R2, what you have is that you have pairs of PC models such that both speeds of uh, PCs in those pairs, they are greater than 2.8 gigahertz, right? Now the question is that we want to find the manufacturers who have at least two different PCs, right? So now both these, in the pairs that you have in R2, right? They may be from all different manufacturers also, but we want only those pairs where I have, models are from the same manufacturer, right? Okay. So now how do we do that? So do that, in order to do that, what we first find out is that first we find out uh, those tuples, from here, those tuples from here, which belong to PC, but they are different models and the maker is same. So in order to get that, what we do is that we create two copies of the product. So this P1 and P2, they are basically copies of the product table. Because the space was less in this slide, so therefore I did not specifically write product to P1 and all that. This P1 refers to a copy of product and this P2 refers to another copy of product. So here also we are doing a self join between two copies of the product relation, and my join condition is that first of all, the both P1 dot type is equal to PC and P2 type P2 dot type is equal to PC, right? So basically we have taken two instances of the product relation and we have basically thrown out all the tuples where the type is not PC, right? So where the types are laptops and printers, we have thrown out all those tuples, and now we just have those set of tuples where the product type is PC. And now imagine that in those lists of PC, I do a cross product, I Cartesian product, and then I filter out on the condition that out of all those, the maker should be same. That means, if P1 dot maker is del, then P2 dot maker is also equal to del, and the model should not be same. So after doing all of these conditions, what R3 will contain is R3 will contain those tuples where P1 dot maker equal to P2 dot maker and P1 dot model is not equal to P2 dot model, but whereas type is PC. So in other words, what R3 will contain is R3 will contain tuples corresponding to those makers who have created at least two different PCs. They may have created three or so or more, we don't care, but at least they have two. Because what will happen is that if there is a maker who has created only one type of PC, then that will never match this particular condition. Or if you have a maker who has never created a PC, then even this will also get thrown out, right? So therefore, if we have if there is a maker who has created at least two PCs, with different model numbers, of course, then those corresponding tuples will be sitting in this R3, right? Now all we have to do is that we have to join this R3 tuple, R3 relation, intermediate relation, with R2 intermediate relation. Remember that R2 was basically was containing pairs of PCs whose speed were greater than 2.8, and now R3 is also containing pairs of PCs where maker is same. Now you just have to match the model numbers across R3 and R2 intermediate relations, and that's exactly what R4, this step, fourth step is doing. Here what we are doing is, we are joining R3 with R2 on the condition that P1 dot model is equal to PC1 dot model and P2 dot model is equal to PC2 dot model. So that means, if there is if there is a match between R3 and R2, then that means that those tuples corresponding to those makers, who have created two models, but the speed is greater than 2.8, right? And then finally you filter out the maker column, right? And this removes duplicates automatically. So this is how it works. Again, this is a very fairly complicated logic over here. I would strongly advise you to take a piece of paper, create three tuples in product, right? So you make all of them as PCs, but you select the maker accordingly. And similarly, you create some tuples in PC also, right? So work it out. It I think it will come out just fine. Okay. Okay. Another thing which I wanted to say here is that here I have this phrase at least two. If I had written at least three different PCs, then how would you have done it? Right? So if I had given you at least three in the question, then you would have to do an three-way cross product. You have to take three copies, and then you have to write here PC1 cross PC2 cross PC3, and then in the selection condition you have to say that PC1 dot model not equal to PC2 dot model not equal to PC3 dot model, right? So that is how you generate tuples for three or more different PCs. Now if I say exactly three different PCs, then that's a whole different ball game, right? So maybe in one of our online live sessions, I'll actually cover a case where instead of at least two different PCs, what if I change the query to exactly two different PCs? That means even manufacturers who have created three PCs with speed greater than 2.8 are not valid. Okay, so I'll cover that in one of the live sessions. That is the best way of doing it. Okay. Okay, so this is the last query in this particular video. Okay, so here we want to find manufacturers of PCs with three different speeds. So that means we want to find those makers who have created at least three different PCs for sure, and the speeds of those three different PCs also must be different. It's not just that they created three different models. The speed should also be different. Right? Now, how do I get that? Okay, so let's see here. Okay. So this also has a very similar flavor to our previous query, but in previous query we had two different, now we have at least three different, right? So as I said before, whenever you have to do something like three different or four different, right? So you have to consider cross products with itself. So instead, when we are doing three different, then we have to take three copies of PC and perform cross product among all the three copies, right? So here I have taken three copies of PC, and I'm performing a Cartesian product among those three, and then I'm then performing a selection operation, right? So again, the selection condition is long, but don't get scared here. So the first part, this part, so what this is doing is that it is creating triples of PC models, right? So let's say if you have let's say model 10, 11, 12, then that triple, which contains, any permutation of that 10, 11, 12, that is a valid triple, right? So there PC1 dot model is not equal to PC2 dot model is not equal to PC3 dot model, right? So with just this part, you create triples of PC models. And then the second part, what it is doing is that, let's say, you create these valid triples, and then, you sort of, conceptually loop over all those triples, and then you filter out only those triples where the speed of the three PCs which are involved in that triple, they are different, right? And if no, if there does, if for example, if all the speeds are same in your PC table, or if you do not have three unique values of the speed in the speed column, then this will not give any result. This will give you a null. But otherwise, if let's say that uh, let's take an example here. So let's say that you have 10 PC models, and 7 of them have identical speed for our example, right? So let's say that identical speed is 10, right? And then you have maybe, uh, two different speeds again, right? Maybe, 11 and 12, right? So now when I say triples, then what will happen is that, so this 10 and 12 will sort of pair with each of those 10 speed tuples to create valid triples, right? So that's how it creates. And note that, you will get permutation. So let's say if you have PC models, let's say, 100, 101 and 102, then this R1 will contain all permutations of those three model numbers, because, that's how it is when you do a cross product. But nevertheless, the information is there, right? So to summarize, R1 will contain triples of PC models such that the speeds of the models are different, right? Now, what we have to do is that we have to find manufacturers, and we have to check if there exists any company who has created three different speeds, because, from R1 you just get three different speeds. Now it may happen that, all the three models involved in that, they may be manufactured by different companies, but that's not what we want. We want to find out if the same manufacturer has manufactured all the three or not. In order to do that, we will create triples of PC models from your product relation. Right? So here I have taken three copies of the product relation, P1, P2, P3. I have done a cross product among these three. And the first check which I am doing is that, the type should be PC. That means, trivially, all the tuples where the type is laptop or printer, they are straight away thrown out. And then among the remaining ones, you sort of create triples, and then, in that triple, what you are checking, you are checking two things. So first thing is that the maker should be same, and the second thing that you are checking is that, the model number should be different, right? So the first check, this part, is sort of, taking care of only the PCs. That means, I'm not interested in laptops or printers. And then this selection condition and this particular selection condition, what they are doing is that they are making sure that I get only those tuples corresponding to makers where the maker has created at least three different models, right? Because if there does not exist any manufacturer with three different PC models, then, we can just forget about even checking this second part of, at least three different speeds and all that, right? So R2 will contain tuples corresponding to those makers who have created three different PCs. Now what we do is that, we perform a natural join of R1 with R2, right? And I wrote here natural join, but, you could have again made it a theta join and all that. So in this R2 R1 natural join R2, what I am doing is that this natural join will happen on the model number, right? So the model number over here will get matched with the model number over here. Now, when these two joins, then what will happen is that if the maker over here who has created three different models, if that guy, those three models happen to have different speeds also, then they will match, right? And then they will get filtered out in the final result. Again, this is a fairly involved query. So as I always say, take your time, try to understand it, and if you don't understand, let me know. I'll try to have an live session on this, at least this style of at least two different queries, or at least uh, or as I said before, instead of at least, if I say exactly three different speeds, then how will you do it and all that, right? So we'll work out. Okay, so one important thing which I wanted to mention over here is that when I'm explaining these relational algebra expressions, I'm not considering about the efficiency, right? Whether I should execute this first or this first, right? This is a whole lot of engineering which goes into it. Again, remember that I think in the earlier also I said that in relational algebra expression, all we need to care is about the correctness, mathematical correctness of your query. Do not think about efficiency. For example, you may say that creating this three-way cross product is hard. Why not let's do a join, right? And should we execute this first or this first? There's a whole lot of science and engineering which goes behind how to plan a query execution. But that is all in the later part of our uh, class, later part of our course, where I will be talking about query optimization. As of now, you do not think about efficiency, you just think about getting it conceptually correct. Okay, so make sure you practice these questions, understand them well. Okay, then let's see, do I have other, I do have other questions, but I think you should sort of take it as practice questions and work out on your examples. You can expect questions similar to these in your quizzes and all that, right? I can give you a schema, and then I'll ask you to write a relational algebra expression for these particular schemas, right? So you should be well versed. As I keep saying, do not mug up, catch the concept how it is done. Okay.